So today I'm going to talk about an app called Areoi. So what's the main idea of this application is to give new perspective to the people who are in need. In this scenario, they are the blind. So in the picture as shown, with the help of human hands, I'm trying to remove the dependence of blind people so that they can be mentally strong. Moving on, the aims and objectives. The aim is very simple that you should give a new sense of vision to the blind. Obviously, they have a problem to their eyes, so they can use modern advanced technologies. With the help of modern advanced technologies, they can see or sense what is around them, and which makes them mentally stronger because they can be less independent, like more independent and less have to depend on somebody to get their things done. And the objectives are using LiDAR technology, um, which is radar based technology, which is mostly used in the military. Now it is moving into the consumer market. So, with the help of an IoT device or an existing mobile phone, the LiDAR sensor can be implemented and the data collected can give them information around their surroundings. Next is text to voice and haptic system provides a blind a fresh viewpoint. What I mean by this is using the data collected by the LiDAR sensor, haptic motors, and text to voice technology can be implemented in the application so that they can understand what is around them. Uh, then there is this GPS technology implemented in the app, which also works with the help of gyroscope and accelerometer to understand how much calorie they burn or how much distance they walk, or in case of an emergency, they can use the data in the application using pair of spectacles, which is so basically a blind person always have to depend on sunglasses because they have to cool down their eyes. When it comes to indoor, they typically prefer not to wear a sunglass, so uh, they depend on they walk straight away. So using the mobile phone, the indoor mode can be really helpful. And like I said, caretakers can monitor their daily activity. Basically, I've selected the UX research method as Lean UX, which is basically it gives instant formation of information, and I can complete as a loop, like collect the information. If I find it wrong, I can go back again. So it's flexible. So that's why I went for the user research UX research method. I have done a couple of things like user persona, ideation, create, rapid idea generation, low five, mid five, and I've based on the prototype I've created, I have done user testing, which will be said further down the presentation, and created a SAS score out of it. Moving on, the background research involved. Basically, the background research involved was about LiDAR scanners. I was trying to understand how important and how difficult it is to work with LiDAR. But it is a very modern technology which has got a lot of potential into it. So I figured that devices like the iPhone features a LiDAR scanner to have realistic depth data. And also, while collecting the data, I've also decided to make an IoT device to for the target users so that they can purchase this glass, which looks like a normal glass, but it's got all the necessary sensors and a haptic motor engine and a speaker as well implemented into it, so that the information provided by the application can smoothly work uh, with the glasses. Moving on, these are the quantitative and qualitative research which is done. I created a Google survey. I received around 39 responses for it, and based on the data collected, I have further moved for the development stage. Based on the data collected from the previous sections, I have created a problem statement, which is to make the blind people socially more active rather than thinking about their disability and not going out. So, this application opens a wide stage of um, environment for the people to move outside with the mobile phone or the IoT device, which is mentioned previously, to get a new sense. And also for the caretakers, they can monitor them uh, with a bit more support with the help of this application. But um, the problem what they face is the blind person is always concerned that he always have to depend on somebody to do his daily task. And with this application, I strongly believe that there is a higher chance of removing this problem. Moving on, these are the three behavioral designs I have chosen, which is Z pattern. Based on the studies, a human being can I moves in a Z pattern. So basically, all the components in the application is designed in such a manner. And the main factor which is considered in this application is conversational design. So conversational design is implemented very well based on the research conducted previously. And nextly, the ostrich effect satisfying method is also implemented on the navigation system part of the application. The first hypothetical statement denoted was, I think integrating a LiDAR scanner and AI would provide accurate information on the user Nathan about the surrounding, motivating Nathan to use the app again. So AI, these are the two screens from the application which shows the hypothetical statement, which proves the hypothetical statement, and it has worked very well. Moving on, hypothetical statement two. I believe adding a GPS tracking capability together with accelerometer and gyroscope integration will make it easier to gather location and health data, allowing caretakers to use the app more effectively look after the patients. So basically, the first screen shows that there is different modes for users. Uh, if he's a caretaker or if he's the patient, they have different modes, which is fine tuned to their needs, and this like the lack of information, more information will be provided based on this uh, user modes. So this particular statement was developed for support workers who need accurate information to keep track of how the patient is doing well. So in this scenario, the existing technologies in the mobile devices can be used like gyroscope and accelerometer to determine their health status as well as their location, which will be really effective. And these three screens is what I have included myself in. I think the additional IoT device will be provide immediate feedback on the environment, and when combined with the AI-powered text-to-speech technology, will help to offer user a new sense. Like I said, this app is heavily depending on voice system because the blind people cannot see and they depend on um, other senses like touch and feel. So, and voice, obviously. So, the voice technology is added, and based on the statement three, I've created the app to have text to speech uh, engine built in, plus an IoT device to give them sensors. So basically, if they're outside, if they purchase this uh, prescribed specs, they can get their senses to the next level, like having perfectly tuned with the application. And these are the hypothesis success, and based on the SUS score, they have rated it 85 and 72.5 respectively, and which is a 78.75%, and which denotes that it's a success. The users are satisfied with the way the application feels and how it works. And moving on, based on the hypothetical statement which I've developed, the success rate is 100, 80, and 90, and which gives us a grand total of 90, which proves that the application and the engine and the information and the technology surrounding this platform is a 90% success. This is the end of the presentation. And like the image shows, I strongly believe that this application can give a brighter light to the blind people who are in need. And as a person who studies technology, I hope that new technologies can be pushed towards people who are with disabilities. Thank you.